presently we are going through a series of computer networks, and the topic which we are going to cover today is about sliding window protocols. And within the sliding window protocols, because there are kind of we can say two flavors of sliding window protocols, one is go back and another one is selective repeat. So we are in this lecture we are going to go with this go back end protocol. Now let us begin with the concept of sliding window protocols. As we are kind of presently covering data link layer protocols, sliding window is also one of them, and this is actually required for reliable and sequential delivery of data frames. And this concept of sliding window protocols is also used in TCP, which is transmission control protocol. So previously we have seen simplex, the utopian simplex, which was kind of an hypothetical protocol. Then we have seen stop and wait protocol also. But in sliding window protocol, in a stop and wait protocol, there can be only one particular frame which was kind of sent from sender to receiver, and receiver will wait for the acknowledgement of that particular frame, and then after getting the acknowledgement only it is supposed to send the next frame. But here in sliding window protocol, multiple frames can be sent by a sender at a time, even before receiving the acknowledgement from the receiver. Now this term sliding window refers to the imaginary boxes or imaginary kind of windows which are going to hold the frames. This sliding window method is also known as windowing. This sliding window technique takes place with varying limits on the number of data packets that are sent before waiting for an acknowledgement signal back from receiving the computer, from the receiving computer, and the number of data packets which can be sent before waiting for an acknowledgement is called the window size. So for example, let us say we have a window size of 3 packets, then 3 packets can be sent, and then one can wait for an acknowledgement signal back. And if kind of we can say next next 3 packets are to be sent, so then it's a slide onto the window, and this number of data packets is called window size. Now let us try to kind of deep down into the working principles. So in sliding window protocols, when we talk about the sender has a buffer which we called sending window. Similarly, on the same lines, the receiver has a buffer which we call the receiving window, and the size of the sending window determines the sequence number of the outbound frame. So there is a kind of we can say close connection between the window size and the sequence number. That also we will be kind of covering in our upcoming slides. So if the sequence number of the frame is in, let us say, n bit field, then the range of sequence numbers that can be assigned is from 0 to 2 to the power n minus 1. Consequently, we can also say that the size of the sending window is 2 to the power n minus 1. So in order to accommodate a sending window size of 2 to the power n minus 1, and a n bit sequence number is to be chosen. We will be looking into examples of these with 3 bit with 3 frame window or with the 4 frame window as well. And the sequence number here are going to be numbered as modulo n. So let us take an example for this. Let us say we have a sending window size of 4. Then the sequence numbers will be 0, 1, 2 and 3, then 0, 1, 2, 3 and again 0, 1, 2, 3 and so on and so on. So the number of bits in the sequence number is 2 to generate the binary sequence 0, 0, 0, 1, 1, 0 and 1, 1. So window size is 4 and the sequence number will be 0, 0, we can say for 1, 2, 3, 0, 1, 2, 3, it could be 0, 0, 0, 1, 1, 0 and 1 1. So this is, you know, the total number of bits required in order to generate this binary sequence is obviously, you know, we can see 2 places here. So 2 is there. Moving further, if you can say what about, you know, if we need to pass some comment on the size of the receiving window. So size of the receiving window here is the maximum number of frames that a receiver can accept at a time, and this you know, size of the receiving window is going to determine the maximum number of frames that the sender can send before receiving the acknowledgement. So, you know, if it is a kind of 4 sized window, or if it is a window of size 4, that means 4 frames can be sent before receiving the acknowledgement. Now, please recall the stop and wait protocol, in which there was only kind of, you know, we can say one particular a frame can be sent, and the acknowledgement has to be kind of, you know, the sender side has to wait for the acknowledgement. So, here in order to understand this concept of you know, sliding window protocol, we have a figure in which on the left side, if you can see, there is kind of a window which is having 4 frames, and these 4 frames are 0, 1, 2 and 3. So, if they are, you know, kind of going to be sent from sender to receiver in a sequential manner, so we can say, you know, window is slided window is slided if an acknowledgement is received. Let us see how. So, here you can see in the next half of the screen, you can see there is a sender and a receiver. Now, our window is of 4 you know, size 4. So, sender can receive 4 frames without waiting for the acknowledgement. So, it is going to send 0, it is going to send 1, it is going to send 2, it is going to send 3 as well, and without waiting for the acknowledgement for 0, it is going to send 1. Without waiting for the acknowledgement of 1, it is going to send 0. Without waiting acknowledgement for 2, it is going to send 3. So, 4 frames it has sent, and now, you know, it will wait for the acknowledgement, and then an acknowledgement for frame 0 has been you know, received. Now, when acknowledgement for frame 0 has been received, this essentially allows this sequence number 0, or in binary we can say 0 0, to be used again. Now, at the next moment, if the acknowledgement for the frame number 1 is going to be, you know, kind of received at the sender end, then in that situation, you know, the sequence number 0 1 can be used again. So, it is kind of a sliding window. So, for example, for 0, as you can see, the acknowledgement has been received. So, 0 now can be, you know, kind of resent or reused as a sequence number, and that is why this window has been slided, if you can see, from 0 to 1. So, now it is waiting for other acknowledgements 1, 2, 3, while 0 can be reused, the sequence number 0 can be used again. And for, you know, in order to represent the sequence number within a window size of 4, obviously we are not going to require 2 bits, as we have seen in our earlier slide, which was 0 0 0 1 1 0 and 1 1. So, in this way, these sliding protocols, if we talk about that, these sliding protocols are going, sliding window protocols to be more specific, are going to work. Now, let us look into, you know, the advantages of sliding window protocol. Now, it is possible to send multiple packets without receiving an acknowledgement, that is perfectly allowed, which was not allowed in stop and wait protocol. Now, piggybacking with full duplex lines is possible. Now, here we have a new term which is, you know, piggybacking. So, piggybacking actually is a technique where the receiver delays sending an acknowledgement and attach it to its next outgoing data packet. So, here till this point, whatever, you know, kind of communication style or communication pattern which we have seen, communication technique which we have seen is, they both are, sender and receiver both are not transmitting at the same time. But when we talk about, you know, kind of a full duplex system, in a full duplex system, you know, your receiver delays the acknowledgement and it is going to attach to its the next outgoing data packet which is going to be from receiver to sender. So, what will kind of happen if this kind of piggybacking is allowed? So, obviously there is no need to send a separate acknowledgement or acknowledgement only. This can be kind of sent with that outgoing data packet. So, because of this, the number of separate control frames is going to be reduced, and hence it we can say it is going to improve the network efficiency. The first advantage was of sliding window protocol is sending multiple packets without waiting for the acknowledgement. Second, piggybacking with full duplex lines is possible. Now, as to two sides of coins are there are also disadvantages of these sliding window protocols. The protocols does not impose any specific restrictions on the sequence number, then this is certainly a disadvantage, and in some cases there could be we can say a wastage of bandwidth. So, with this background of sliding window protocol, or more specifically we can say sliding window ARQ. So, ARQ, as you all are aware by this time, is automatic repeat request. So, sliding window ARQ is now having two different types. One is go back N ARQ and another one is selective request ARQ. So, here today we are going to look into this go back N ARQ in detail. So, it is also a sliding window protocol, as I have already told you. Go back N, when kind of written in short form, is GBN, basically a sliding window ARQ protocol that allows the sender to transmit multiple frames up to a defined window size, and we have seen the example of 4 without waiting for individual acknowledgements. And this N, the kind of the variable N, if you can see, is actually the size of that window. For example, if we are talking about 4 frames to be sent at a time without waiting for the individual acknowledgements, the example will be of go back 4. So, that is the number N. So, moving further, this go back N ARQ is again automatic repeat request, provides for sending multiple frames without receiving the acknowledgement for the first or even for the second frame. Obviously, it is using a concept of sliding window, and hence it is kind of falling under the category of sliding window protocols. Now, here the important thing is, as we have seen in sliding window, as we have seen in basic sliding window protocol, the frames are sequentially numbered and a finite numbers of frame are sent at one point of time. If the acknowledgement for a frame is not received within a time period, all frames starting from that particular frame are retransmitted. So, here in order to understand the concept of go back N sliding window, I am going to repeat this. Frames are sequentially numbered and a finite numbers of frames are sent. So, if the acknowledgement of a frame is not received within the time period, all frames starting from that frame are retransmitted. If a packet is lost or corrupted, the sender will retransmit that packet and also all the subsequent packets in the window. Now, this is very important. If a packet is lost or corrupted, the sender retransmits the packet and all the subsequent packets in the window also. So, for example, let us say we have a window size of 5, let us say. So, if there are 5 packets numbered from 1, 2, 3, 4, 5 are sent, and let us say packet number 3 is lost and there is no acknowledgement for packet 3. Then all the packets or all the frames starting from 3, which are nothing but 3, 4 and 5, are supposed to be retransmitted, and this is what the concept of go back N. So, go back 3, if we can say. So, everything from that 3 to the total N is going to be retransmitted again. So what happens in this mechanism? This mechanism also this ensures the reliability, fine, that is there, but it may waste bandwidth if errors occur frequently. So every time, let us say in every transmission of this 1 to 5 year packet number 2 or packet number 3 is getting lost. So all the subsequent frames are again going to be retransmitted. So obviously there is a wastage of bandwidth if errors are occurring frequently, although this mechanism ensures reliability also, but that reliability is having a huge cost. And in order to maintain this thing, the receiver process is going to keep track of the sequence number of the next frame it expects to receive and sends that number with every acknowledgement it sends. So, for example, 0 is received, then 1 is received, then 2 is received, and so on and so forth. So, whatever frame or whatever packet has been received at the receiver end, acknowledgement has to be kind of, we can say that acknowledgement is to be concatenated with that number your kind of receiver is sending. So, for example, and obviously in case of, let us say for example, 3 was lost, as I have taken an example, 3 was lost and then 3, 4, 5 are being kind of resent again. And what is happening at the receiver's end is 4 and 5 are intact, although 3 was lost. So, that means now it is having 4 and 5 in kind of, we can say duplicate. So, receiver is going to discard any duplicate frames. Also, it is going to discard any frame that does not have the exact sequence number which the receiver was expecting. So, let us say for example, receiver was expecting 3 and now it is coming up as 5, or maybe it is coming up as 0, then that is not the sequence number it was expecting, and it will resend an ACK acknowledgement for the last correct, that means for second, so that it is going to, it is because it is expecting 3, so an ACK2 is again resent. So, receiver will discard any frame that does not have the exact sequence number it expects and will resend an ACK for the last correct in order frame. Now, looking into the characteristics of this go back n, which is GBN, there are basically 3 main characteristics of this protocol. One is the sender window size, another one is the receiver side, and third one is the acknowledgement, and within that we will also talk about the types of acknowledgement. So, let us try to kind of figure out these 3 main characteristic features of go back n. So, one is sender window size, which is denoted by W, and within the subscript we have S. This is nothing but that number n itself. So, if we say the protocol is GB10, then window size of the center, which is WS is obviously 10, and n should always be greater than 1 in order to implement pipelining. Now, why? Because if when your n is going to be equals to 1, your sliding window protocol will eventually turn into your stop and wait protocol, because in a stop and wait protocol 1 is sent and then the sender is waiting for the acknowledgement. But here the main characteristics of the sliding window is multiple frames can be sent without waiting for the acknowledgement. So, obviously we are expecting n to be greater than 1 in order to implement pipelining, otherwise it will be kind of just a stop and wait protocol. Now, for example, as I have told you, for n is equals to 1, it reduces to stop and wait protocol. Efficiency of this go back n is n divided by 1 upon 2a, where a you all are aware, we have seen in our previous lecture that this a is the ratio of propagation delay to transmission delay of the sender, which is Tp divided by Tt. So, n divided by 1 plus 2 into TP divided by TT, which is propagation delay divided by transmission delay of sender. The second major characteristics of the receiver of this go back N is the receiver window size, which is again denoted by capital W subscript R. In go back N, it is, we can say it is always 1, because receiver only accepts the next expected packet. Out of order packets are discarded, I have already told you. So, receiver is going to accept the next expected packet. Out of order packets are obviously going to be discarded. So, the receiver window size is 1. Moving on to the next characteristic of this go back N is acknowledgement. Now, one thing which is important here is acknowledgement. Now, if we want to define this acknowledgement, we can say these are the signals sent by the receiver to confirm successful receipt of data packets. So, acknowledgement is a kind of signal through which a receiver is going to tell a sender that yes, data packets have been kind of received successfully. This is a way of ensuring reliable communication between the two parties, sender and receiver. And if an acknowledgement obviously is not received within a set timer, within the set time for which a timer is actually, timer starts the ticking when the sender sends the frame. And if an acknowledgement is not received within the time limit which is set, the sender assumes that the packet is lost and hence it is going to retransmit it. So, sender window size, the receiver window size and the acknowledgement are basic, we can say characteristics of this go back N protocol. Now, if we talk about the acknowledgements, we will look into the types of acknowledgements also. So, there are basically two types of acknowledgements. One is a cumulative acknowledgement, another one is an independent acknowledgement. So, when we say cumulative acknowledgement, a single acknowledgement which confirms the receipts of all packets up to a certain point. So, for example, if I am going to send this ACK4, that means till 4 all the packets are received. What is the advantage of this kind of cumulative acknowledgement is there is lesser traffic because acknowledgements are fewer, but the disadvantage it is less reliable. If one acknowledgement is lost, multiple packets go unacknowledgement, because this is not an individual kind of individual one-on-one acknowledgement. So, if that ACK4 is lost, so in case of loss of ACK4, all the packets 0, 1, 2, 3, 4 will be kind of retransmitted. So, because sender is not aware that the acknowledgement has been lost. So, if the acknowledgement does not appear at the kind of senders and multiple packets will go unacknowledgement. So, in this way it is kind of, this is a major disadvantage of this cumulative acknowledgement. Now, another type of acknowledgement could be independent acknowledgement, in which, as the name suggests, each packet is acknowledged individually. Now, the advantage, the high reliability, or the what was the disadvantage, that less reliable, what was the disadvantage of the cumulative acknowledgement system was less reliability if one of the acknowledgements is lost. So, here if we talk about independent acknowledgement, the advantage here is the high reliability. Disadvantage, because every individual packet is acknowledged separately, obviously this is going to result in a higher traffic because of so many acknowledgements. So, here in this lecture we talked about sliding window protocol. We looked into the concept of sliding window protocol in a nutshell in a way, we recapped it. Then we started with go back N protocol, and we tried to understand what actually this go back N protocol is, along with the characteristics of this go back N protocol. Here is a list of references which is being used for the preparation of lecture. I hope you have enjoyed this one. I will see you in the next along with the left material of this go back N, or we can say the second part of this go back N soon. Till then, take care. Goodbye.